Hey, math fans, welcome to another episode of Math 1 Honors. We're in section 1.2.1. Let's get started. James earns $15 per hour as a teller at a bank. In 1 week, he pays 17% of his earnings in state and federal taxes. His take-home pay for the week is $460.65. How many hours did James work? Okay, so the first thing we're going to do is figure out James earns $15 per hour. And we don't know how many hours he worked. So it's going to be 15 times the amount of hours he worked. Okay. But he's paying 17% of that in taxes, meaning that he doesn't get if he worked 1 hour, he would get paid 1 hour times $15, which would be $15. 2 hours, he'd be making $30. But he's not taking home that amount. Okay. Taxes means he's going to be making less. So we're going to be subtracting off a certain amount. And it's actually a percentage. So the more he works, the more he's actually going to get taxed. So 17%, remember again, is 0.17. Now, if I just leave it like that, that's saying that he's going to work 15 hours. He's going to make, if he works for 2 hours, he'll be making $30. But as I've written it right here, it says minus 0.17. That's not 17%, that's 17 cents. So we need to write it as a percentage of his total pay, which would be whatever he made for 15 hours times the H. Okay, so a couple things to keep in mind is you have your base pay there. And then here's your taxes. And when you pay taxes, it's a subtraction, okay? And it's always, and some people will accidentally put 0.17 and they'll only put the H, but you got to put the 15. I mean, because he's getting taxed not on just 1 hour. If you just put H, he's getting taxed on 1 hour, but he's getting taxed on all 15 hours. So there's your expression right now. But this section is different because we're actually going to solve for the number of hours that he has worked. So we got to finish this problem off by saying what's the total amount that he made, and that is equal to $460.65. And from there we can solve. So that simplifies to this statement, which simplifies to this statement. We divide by $12.45, and we get that he worked a grand total of 37 hours. Go ahead and take a moment, pause the video, and write all that down. And I'm going to move on to example 2. Brianna saved $600 to buy a new TV. If the TV she wants costs more than costs $1,800 and she saves $20 a week, how many years will it take her to buy the TV? There's a couple different ways you can do it, but I would always start here. She's already got the $600. That's not going to change. We can't do anything about, no one can take that $600 away from her. She can only add to that, though, the amount that she's saving per week. And then the grand total of this thing is $1,800. So we got to figure out what goes in there. Well, she's saving $20 a week. So we could write 20W, or we could just write 20X and let X be the number of weeks. We subtract 600 from both sides. We get 20X is equal to 1,200. And then we finally divide by 20. We get X is equal to 60. Okay, we got to be careful here, though. Take a look. It says how many years, but we're letting X be, we probably would have been better off if we made it a W, but this is the number of weeks. So we can't say it'll be 60 weeks, but that's the answer's not in years, so we have to be careful with that. If we want to know the number of years, we need to divide this by, there are 52 weeks in a year. So the final answer is going to be we're going to have to round. It doesn't come out to an even number, but approximately 1.15 years. So be careful with the units on that one, okay? And that's example 2. Let's move on to example 3. These ones, this is a famous problem that adults struggle with this one. And so it's best to kind of just slow down. I would say I'm going to draw a picture too to kind of help us through this. But we're going to be using this formula. Distance is equal to rate times time. So keep that in the back of your mind. Okay, so these two brothers are 55 miles apart. One's going to be traveling, they're going to meet in the middle. One's going to be traveling this way, the other one's going to be traveling this way. And if you think about it, the distance this brother traveled versus the distance the other brother traveled, we're going to be adding them up. So let's talk about the first brother first. So the first brother is traveling at 60 miles an hour. So we're just going to let's write 60 times t. And the other one is traveling at 70 miles an hour. So if they were both traveling for 1 hour, this brother would travel 60 miles. This brother would travel 70 miles. Altogether, traveling an entire distance of 130 miles, which means that this is definitely going to be less than an hour, okay? So what we're going to do is we're going to see, when does this become equal to the 55? When does 60t plus 70t equal 55? So we just solve. I'm going to go ahead and finish this problem up here. I kind of ran out of room. So now we have to divide by not 55, but now we have to divide by 130. So be careful there. What's 55 divided by 130? Well, I'll tell you this, it's not a number bigger than 1, okay? So our final answer is going to be t is equal to whatever 55 divided by 130. If you have a calculator, it comes out to, I should put approximately, double squiggles here, approximately 0.423 hours. So not even quite a half an hour, okay? These two brothers will meet in the middle. Okay. Correction, they're not going to meet in the middle. Obviously one is traveling faster than the other. In this particular problem, example 4, they're just asking you, think about the units. What would make sense here? The rate at which your water fills up a swimming pool. What units would you use? I don't know about you, but if you're measuring really big units of water, we tend to use gallons, right? And it's probably going to be so many gallons per hour. The cost of tiling a kitchen floor, well, it's usually the amount of money. So we could say dollars. We wouldn't use cents because it's definitely going to be dollars per. We measure flooring in square feet. Okay. Average speed of a falling object. Well, objects fall fast, so we're not going to say miles per hour. And they usually don't fall that far, so we'll probably say, how many feet is it going to fall per second? The rate at which a snail travels across a sidewalk. You could do inches, I guess, per second, but I think it would make more sense to go, how many feet has this snail traveled per minute? And the rate at which a room is painted will be square feet again, because remember, flooring and anything having to do with houses, painting a room or tiling a floor is square feet per hour, I would say, because it's probably going to take you a few hours to paint a room. So here, Ernesto built a wooden car for a soapbox derby. He is painting the top of the car blue and the sides black. He already has enough black paint, but he needs to buy blue paint. He needs to know the approximate area of the top of the car to determine the size of the container of blue paint he should buy. He measured that the length to be 9 feet and 11 1/4 inches, and the width to be half an inch less than 3 feet. What's the surface area of the top of the car, and what is the most accurate area measurement Ernesto can use to buy his paint? First things first, this is the first thing I would do is draw a picture for this one, definitely. So let's draw the top of this car, and I'm using blue because they said it was blue. Next thing we should be doing, and I'm going to change the color and do these calculations up here. They're being kind of confusing here. We have to figure out what these are, and we need a common measurement. So let's start with the 9 feet and 11 1/4 inches. Okay, so let's convert everything to inches, no feet. So 9 times 12, we're going to multiply those together first. And then we're going to add 11 1/4, and notice that I wrote it as a decimal. That'll make it easier on us. So all together, this is 119.25. Now let's take care of the width. So we want to keep this also in inches, so let's convert 3 feet to 3 times 12 inches minus a half, and I wrote it as 0.5 because we're going to keep it as a decimal, minus a half because it says it's going to be a half an inch less than 3 feet. And that turns out to be 35.5 inches, and I wrote them over here on the top. Now this is the top of the car, and so now we want to find the area. So remember, the area of a rectangle is equal to the length times the width. And when you calculate all that out, you get 4,233.375. Remember, this is in inches. Inches squared, because we're doing inches here. Inches times inches will get you inches squared. So it's 4,233.375 inches squared. Now I'm going to erase this, so make sure you got this down. I'm going to erase this and going to figure out how many square feet that is. So with 4,233.375 inches squares, what we're going to do is we're actually going to divide that by 144, because there's per 1 foot, there's 144 inches. So when we divide that out, we get approximately 29.4 feet squared. And there you go. This was section 1.2.1. Have fun practicing. We'll see you in class.